Good morning or good afternoon, as the case may be, ladies and gentlemen. My name is Kara Warburton. I am recording this presentation after delivering a version of this presentation at the International Conference on Terminology and Artificial Intelligence that took place in Malaysia, Kuala Lumpur, Malaysia, in September 2024. I'm making this recording because several people have asked me if they could see what was presented. So let me get started. My name is Kara Warburton, and I am a terminologist. I am also a professor of terminology management at the Université du Québec at Trois-Rivières in Canada. And I have also taught terminology management at other universities, and I teach other language-related courses such as translation, localization, computer-assisted translation, and so forth. As I said, I was invited by my kind hosts in Malaysia, the Malaysian government and the University of Malaysia, to talk about terminology and artificial intelligence. So let me get started. I was quite honored that the Institute of Language and Literature in Malaysia invited me to give a keynote speech at this international conference on terminology and artificial intelligence. I guess one could say that I have enough experience to talk with confidence about terminology as a discipline and as a practice. But artificial intelligence? Very few people, in fact, are experts in this area. Although I've noticed that many people like to claim that they are. And although I may have a little more knowledge about AI than the average person, the field of AI is as awe-inspiring to me as it is to you. One thing is for sure, AI as a science and technology is constantly changing nowadays. It's impossible, in fact, to keep up with the exploding amount of information about AI that is emerging every single day. Therefore, as I give this presentation, remember, we are all explorers embarking on this adventure. Just a quick slide on my background. Okay, so you know who I am a bit more. As I said, I'm a terminologist, not really an AI expert, but I have been involved in terminology management for about 40 years. I have a bachelor's degree in translation with English, French as my language, master's degree, and a PhD in terminology. My 40-year career has had a focus on commercial and institutional terminology management. I was involved in managing terminology at IBM for 15 years. After that, I set up my own consultancy service, and I provided consulting in terminology management to various companies, including Hewlett-Packard, Microsoft, Symantec, Agilent Technologies, and quite a few others. I have also provided consulting outside of the commercial field, strictly speaking, at non-governmental organizations such as the World Bank and International Organization for Standardization. And I have provided some consulting services as well to government agencies involved in managing terminology, such as the Department of the Government of Canada that is responsible for Termium Plus. I have also been actively involved in developing international standards for terminology resources and for other types of language resources through my participation in ISO Technical Committee 37, which is responsible for developing standards in the area of language resources. I mentioned that I have been teaching as well at university, currently at Université du Québec à Trois-Rivières, but prior to that at the University of Illinois at Urbana-Champaign, York University in Toronto, and I have taught courses in related fields such as critical discourse analysis at the University of Hong Kong, and I have been a visiting lecturer at various universities both in Asia and in Europe. As I mentioned, I do provide consulting services, and I do this through my company called Termologic. You can Google it and find my website. And I recently launched some online courses from my website. So if you're interested in learning more about terminology management, I invite you to explore those courses. Now, just to summarize my interest, I'm not a traditional / classical terminologist in the sense that I want to explore the use of terminology resources beyond the conventional or classical use case, which is for translators. Terminology resources are primarily and historically always being used by translators to help them translate text. That's true, and it's still the case. But terminology as a digital resource, if it's properly structured and enhanced, as I will explain in this presentation, can be used in various types of natural language processing applications. And AI, artificial intelligence, is a form of NLP application. It is a natural language processing application. Therefore, theoretically, we should be able to use terminology data in AI as well. Hence this presentation. And my approach to managing terminology is heavily based on the use of corpora. I'm very interested, for example, in term extraction and so forth. So that's me. Let me move on. Otherwise, we'll be in this presentation for 2 hours. So today, I will try to shed light on the key question of the conference. That is, what is the relationship between terminology and artificial intelligence? Note that I said shed light on and not answer the question. The reason for that is that actually, I have discovered with some concern that the relationship between terminology as a discipline and AI has been largely ignored by the so-called AI experts. Few people are asking this question. Indeed, sometimes I feel I'm the only one asking this question. It's as if terminology as a discipline and as a resource is completely under the radar of the AI discussion. That is not a good thing, in my opinion. Hence, I applaud the organizers of the conference where I gave this presentation for having the acute foresight and awareness to have brought us together on this subject. I will approach the question from 2 angles. First, can terminology be in the service of AI? What I mean by that is, can terminology help to improve AI? And second, can AI be in the service of, or help, terminology and terminologists? You will soon see that I give more attention to the first part, terminology helping AI, and less to the second, AI helping terminology. I wonder if that in and of itself means something. Here I break down the 2 questions a bit more. For terminology in the service of AI, we can ask, are the theories, principles, and methods of terminology work applicable for building linguistic resources to enhance AI? And can terminological resources feed into AI? For AI in the surface of terminology, we could ask, can linguists use AI to build terminology resources? Or even, will AI replace terminologists eventually? This last question is one that people in many professions related to the language industry, and in fact outside of the language industry as well, are asking themselves. In particular, translators who are worried about how machine translation, which is a form of AI, and generative AI as well, might change their jobs, might reduce their opportunities for employment, might make them redundant. I would not say that, but there is some hesitation and some concern among translators right now as to the future of their profession in the presence alongside AI. Okay, moving on. So I'm going to start with the first question, terminology in the service of AI. And with regard to this question, I will demonstrate that terminology as a discipline has a key role to play in the future of AI. All right, let's get started. First, I need to clarify what terminology actually means. The word terminology has 2 meanings listed here. The first meaning is terminology is a set of terms from a language for special purposes, or LSP. For example, chemical terminology, legal terminology, and in the commercial world, for example, we could talk about a company's terminology, Microsoft terminology, I don't know, Facebook/meta terminology, and so on. So this is the meaning that most people are familiar with. When you use the word terminology, most people will think you're talking about a set of terms. The second meaning is that terminology is a sub-discipline of linguistics related to, but different from lexicology. It's related, it's closest related discipline. Now, most of the time in this presentation, when I use the word terminology, I'm referring to the second meaning, the one in yellow here. I'm referring to the actual discipline. And often in my writing, I will use the capital T when I'm using the word terminology in this sense to distinguish it from the lowercase terminology, which could usually mean a set of terms. Okay. All right, moving down. Okay. It is important to understand that the discipline of terminology has a long history. Heinrich Pasch from France and Charles Sanders Peirce from the United States developed and adopted a semantic orientation to their study of terms and concepts way back in the mid to late part of the 19th century. So we're talking almost, 150 years ago, okay? 1800s, okay? It is this semantic orientation that distinguishes terminology, the discipline, from its sister discipline, lexicology. In the mid-20th century, so some 50 or so years later, Eugen Wüster from Austria further developed the principles and methods of his forefathers and formalized these principles and methods into a theory that he calls the general theory of terminology. With that formalization of these principles and methods, largely carried out by Eugen Wüster, the discipline of terminology was formally recognized as a discipline. It was born. Okay. Now, we can now say 150 or so years later that terminology is a mature discipline. We can say that because it has a solid theoretical basis. It enjoys an extensive body of scholarly literature. There is a proven methodology for managing terminology as opposed to methodology of lexicography, for example. There are technologies available today. Since computers came out, we now have special software and other types of technology that are purpose-built for managing this type of linguistic information, terminology. There are now university degrees and courses that are offered in terminology management around the world. And I might add that Canada was one of the first countries to offer courses in terminology management. And its methods and formats, the methods of terminology management and the formats of terminology resources have been studied and standardized by ISO, in particular ISO Technical Committee 37. Okay, and I've listed 3 standards here that I think are important, but there are others. ISO 704 is about how to manage terminology. ISO 16642 provides a meta model for terminological databases, and ISO 30042 provides an XML-based markup language for terminology resources. Okay. Now, terminology resources have certain core properties that distinguish them, that make them unique compared to other types of language resources. Okay, in particular, what I have on this slide, concept orientations and so on. Okay, obviously, I do not have the time today to describe terminology as a discipline and to go into great detail about what you see, the points that you see on this slide. You would need a full university course for that. You can also take the courses on my website, on the Terminologic website. But nevertheless, the core principles that I have listed on this slide are noteworthy because, as we will see more later, they all have the potential for enhancing artificial intelligence. It turns out that concept orientation, The most important principle in terminology as a discipline is essential for artificial intelligence, as it enables the machine interpretability of language variation. By that, I mean lexical variance and language and terminological variance, synonyms, acronyms, abbreviations, alternate spellings, hyphenation, alternate hyphenation, capitalization. All of this variation in language, including real synonyms like what I call lexical synonyms, like, I don't know, running shoes and sneakers. Okay, so that's what I mean by language variation. And in order to gain a handle on all of these different designations for a single concept, we have to organize the data in using a principle called concept orientation, in a concept-oriented way, okay? Now, after concept orientation would be followed probably semantic relations as an important principle or property of terminology resources, because semantic relations are the basis for machine learning of human knowledge. And we will understand more about this later. Semantic relations are relations between concepts that are related somehow, okay? And in order for a machine to understand, to have a cohesive picture of human knowledge, it has to make those connections between different concepts. Okay. Now, the standardized structure or meta model, coupled with the granular metadata of terminology resources, are the reason why they can be used in various natural language processing applications. And AI is a natural language processing application. Finally, terminology resources today are the only language resources that are truly multilingual. Even translation memories cannot make that claim. They're bilingual. Okay? Terminology resources are truly, this is the only language resource today that's truly multilingual. Translation memories are bilingual, bitexts are bilingual, and so on. Now, as AI seeks to bridge the digital divide between resourced and under-resourced languages, won't they need multilingual linguistic data? So we will see in the slides that follow that these principles are applicable for building the next generation of resources that are going to be used in AI systems. And let me just read what it says on that slide about a terminology resource. I want people to understand what I'm talking about here. A terminology resource is a file or a database that contains terms and associated metadata. Okay. Now, in the next few slides, I'm going to show you what a terminology resource kind of looks like. Now, this is a screenshot from a terminology management system called TermWeb, which is produced by a Swedish company called Interverbum Technologies. I like this terminology management system because it's very robust and it is capable of handling semantic relations, which we need. Okay. Now, let me explain this screenshot. At the top, what you see here is a partial screenshot. The second part is over here. So I'll get to that in a moment. I had to split it in two parts to fit on the slides. So this is the terminological entry for the concept designated by this term, massively multiplayer online game. And below it, you can see MMO, that's an acronym. So these two terms are listed here in this area called English. And you can see that there's some metadata, part of speech, term type, context sentence. A context sentence is a sentence that contains the term and the source of that context sentence. And we have the same here. But above the English language area here, we have, another section. Oops, it keeps going back there. Stop. Okay. This section at the top is called the concept area or concept section or concept level. And that is because it describes the concept before it gets into the specific language terms. So here we have the domain, for example. This is jeux vidéo, that's French for video games. And you can see that there's a number of relations here which are listed and with links. If you click these links, it opens the entry of these other terms. These are not synonyms. These are related terms. They are related in a certain way. We have generic relations here, partitive relations. I guess that's it. Oh, and one associative relation. Oh, I failed to mention, speaking of relations, let me go back for a second. Where was it? The one about the ISO listed. Yeah, this ISO 704 standard provides an extensive list of the different types of concept relations that can be recorded in a terminology resource. So I highly recommend that if you're interested in relations. So let's go back here. Okay, so that's the first part of this entry. This entry is a concept-oriented entry because, and you can see that by the virtue of the fact that it has more than one term, and it has, definitions and relations and so on. Here's the second part of this entry. Still in the English section here, MMOG is another acronym with a context and the source of that context. Then we have the French section, Jeux en ligne massivement multijoueur, with information here, including gender, MMOG as the acronym in French, and MMO also with context sentences. And as you can see, also the name, this was produced by one of my students, Maxime Boutet, in this case, at the Université du Québec at Trois-Rivières. So this is what an entry, a terminological entry looks like. And you can see it doesn't look like a dictionary entry. If you open a dictionary, you will not see a whole collection of terms that name the concept. On the contrary, what you will have is a list of meanings of that single term, of that single word. Multiple meanings. Some words have multiple meanings, right? Some of them don't, but some of them do. And if they do have multiple meanings, they'll just be listed under the word. You can't do that in a concept-oriented entry. Each entry describes only one concept. Okay. Okay, here's a screenshot from another entry, just to show you how we can have visuals. This one was created by Mélanie Laflamme. The term here is algorithm. And you can see you can include a picture, which can be exploded to be easier to view or to see. And this is because being concept-oriented, terminology resources contain terms that name the concept, but also can contain a picture or an image that visually represents the concept, as we can see here. Okay, moving forward now. Now here is a visual of the relationships. Massively multiplayer online game is related to all of these other concepts: multiplayer, non-player, character, alpha test, player base, and so on. And these relations are different, visually represented here by the different endpoints. We have a diamond endpoint here. We have no endpoint in this case. And we have a arrowhead endpoint here. And if I remember correctly, the arrowhead endpoint points to it, represents a generic relation. So a sandbox game is a type of massively multiplayer online game. A pay-to-play is a type of game, and so on. The one with diamonds are partitive relationships, I believe. Alpha test is a part of the game. Player base is a part of the game. And multiplayer is also a part of the game. Actually, the direction of the relationship here may not, I see that there's different directions, so there may be a way, that may be have a certain significance itself. I may be saying that the game is part of the player base or whatever. Anyways, the point being that you can have different types of relations and they will be visually represented by these different arrowheads. In this case, there's no endpoint, and that's because this is an associative relation. Now, TermWeb here in the screenshot I've shown you only has shown 3 types of relations, but you can have many more different types of relations. And as I referred you a moment ago to ISO 704 as a guideline, if you will, of the types of relations that can be recorded in terminology resources. Okay. Now let's talk about AI now. Let's try to understand what generative AI is, or Gen AI. And I've got the two icons here. This is the icon for ChatGPT, and I think this is the icon for Copilot by Microsoft. So there are Gen AI systems popping up all over the place, but these are the popular ones. A generative AI system is capable of generating new text. That's why it's called generative AI. They are built on large language models, or LLM. A large language model is a machine learning model that has been trained on vast amounts of text. Now, general purpose Gen AI systems such as ChatGPT and Copilot are built using general purpose data taken from the internet. Well, I could even remove the word general purpose here, are built using data taken from the internet, are built using text taken from the internet. And each large language model is, large language models contain and are trained on these giant corpora from the internet. And they do refine it by, I don't know, a certain engineering approaches. They do refine these large language models, and then they release different versions. So right now, I think we're at GPT-4. That's the large language model currently used in ChatGPT as I make this video. Because these general purpose systems are using information from across the internet, we could say that they are a general artificial intelligence system, or as written here, Artificial General Intelligence System, AGI system. Okay. But data from the internet, text and data taken from the internet has some issues. Okay, and it is limited, certain limitations. As you can see on this slide, it's not vetted. Anybody can put up a website and nobody is necessarily checking it, except the person who maybe put it up there. It's mostly unstructured. By that, I mean it's HTML markup. It's not highly structured XML. A lot of it PDF files, and there's a lot of unstructured text there. There's not a lot of intelligence in the terms of its embedded structure and markup, which makes the AI system, which makes it more difficult for the AI system to interpret it. It contains inconsistencies, inaccuracies, ambiguities. Not everybody is a great writer. There's a lot of ambiguities because of poor writing style. There are going to be some gaps in the information. So there are going to be some areas that are incomplete and missing information. And of course, bias is also a common problem. As a result of these problems and issues, the AI system is going to reflect those types of issues. In other words, it will produce hallucinations. Hallucinations are errors and inconsistencies and inaccuracies. It will have gaps in the knowledge that it is able to reproduce for you. And some of the information that it delivers in response to a question or a prompt will be out of context. In other words, the system may misinterpret the intention of your question. And this is because it's difficult for the system to filter through the various contexts that your question may be relating to. There could be different contexts, and it won't know which one you are asking about. So as a result, we could say that an AI as it exists today is a reflection of the age-old problem, garbage in, garbage out. Perhaps not totally garbage. We can see some good performance here, but it's not totally reliable, and we all know that. So, suppose a company or organization wants to use AI for some of its operations, but finds the quality of general purpose AI to be unsatisfactory. See if I can move my head a little bit. Okay. The answer to this general AI problem could be to build a custom AI solution. And indeed, there are products and technologies available today for doing exactly that. Now, customized AI uses a customized large language model, one that contains selected, contextually relevant content. Using selected content will raise the relevancy of AI responses to the questions people from that company or organization will be asking. The customized LLM will also, hopefully, be more clean, consistent, accurate, complete, and current than LLMs scraped from the internet at large. Those types of positive features of content are long-standing principles of data quality. And I would imagine that most organizations are aiming for data quality and text quality in their content. So therefore, the content should be fairly good for producing an internal LLM, if you will. This customized LLM will have a higher density of terminology specific to the organization with less interference from other domains. But here's the trick. The LLM can also be enhanced with so-called external sources of knowledge, which contain the semantic orientation needed to enhance machine interpretability of the LLM and of user prompts. So here we're talking about these external sources of knowledge. What they're talking about now in the current discussions about the future of AI are semantically structured lexical resources. Okay, they enable the LLM to be more easily interpreted by the AI system, and it allows the the AI system to also expand on the user prompts through the use of synonyms, for example. The user might ask a question about sneakers, and if there's a semantically connected resource attached to the LLM, the system will know that, okay, sneakers and running shoes, oh, I can pick up information about sneakers, but I can also pick up information about running shoes. Sort of a bad example, but you get the idea. Now, these external sources of knowledge, these semantically structured lexical resources can be built and should be built according to the principles and methods of terminology management, of terminology as a discipline. Now, what we're talking about here is called retrieval augmented generation, or RAG. The approach of using external sources of knowledge to enhance AI is called RAG. RAG is an AI framework for improving the quality of LLM-generated responses by grounding the model on external sources of knowledge to supplement the LLM's internal representation of information. That's a definition of RAG from IBM. These external sources of knowledge are semantic networks of various kinds: ontologies, taxonomies, terminologies sometimes, and more recently, what are known as knowledge graphs. Now, let's hear from my colleague, Michael Iantoska. He was a colleague of mine from IBM some years ago, and he's also an AI developer, and he is considered an AI expert, and he knows a lot about RAG. So let's see what he says about this. If I can get this to work.
Then I began working in the areas of what we call neurosymbolic artificial intelligence. I got turned on in around 2015 timeframe on something called knowledge graphs, ontologies, and taxonomies, and realized that a semantic-based approach to AI was truly the future. And when generative AI became popular in the industry, the models became much more well-known. In my team, and the knowledge platform and engineering team that I manage at Avalara, we began building solutions on top of these large language models around 3.5 years ago. So we're focused today on building more advanced models, what we call advanced retrieval augmented generation, or RAG systems. And I'm specifically building out and making public models that use linguistics, that use language to drive those neurosymbolic knowledge graphs for the next generation from where people are today.
So as you can understand from Michael, these semantic networks, these semantic resources are the future of AI, apparently. Okay, let's move forward. Now, this word cloud was generated by a term extraction tool called Thermostat from the Université de Montréal in Canada. This is a very good terminology extraction tool because it uses a reference corpus in the background to raise the saliency or domain specificity of the terms that are extracted from a corpus. I generated this graph using Thermostat based on submitting several documents, or several web pages, I should say, that described RAG. And this is the picture that was produced, where you can see words like knowledge graph. What do we have here? Cognitive content, content object, knowledge graph, managed terminology, ontology, semantic intelligence, semantic model, taxonomy, term-based terminology, and so on. These are the buzzwords that are currently being used when talking about RAG and the use of these external sources of knowledge to enhance AI. Now, in this slide, I will define or attempt to define knowledge graphs, okay? Knowledge graphs are the main external sources of curated knowledge that are now talked about nowadays in the context of AI. A knowledge graph, also known as a semantic network, represents a network of real-world entities, such as objects, events, situations, or concepts, and illustrates the relationship between them. Knowledge graphs allow AI systems to deal with complex interrelated data. Again, this information came from IBM. Now, let me clarify, first of all, that knowledge graphs are not actually graphs. I mean, the core data is represented in a database, probably a relational database with tables, or I'm not quite sure, but it's data that is in the form of a database. But because those relationships are encoded in the database, they can be reproduced or represented visually, as you can see. This is a sample of a knowledge graph on the screen. Now here we have George Washington, who is a person, an individual, and he has assumed office date 1789, has gender male, has date of birth 1732, is a U.S. president, has property, assumed office date, and so on. Yeah. Okay, so this circle in the bottom is a general concept, but this one is an individual. So George Washington is a person, right? It's an individual. So I think these ones you see, this circle here, and these two here, and this one here, the one I'm just clicking on, 1, 2, 3, 4, 5. These are concepts. And they are actually probably part of an underlying ontology. And then a knowledge graph is a representation of individuals, of entities that fall into those categories of the ontology. So George Washington, for example, is a person. Thomas Jefferson is a person. So this is a general category. These are instances. And then there's the category of U.S. president as well. This is a person who was a U.S. president, and so that one as well. A U.S. president has the property of assuming office on a certain date. So this is a general relationship that has to be established, and then we apply that relationship to individuals. Like here, George Washington has assumed office date 1789. So you can see how this relationship is a model for this one. Okay, now I'm getting tired. Let me move along. You get the idea. You get the idea. Okay. Moving on. Okay. Now here in this slide, this slide helps us to visualize what a knowledge graph can do. The screenshot on the right is displayed by Google when you search for Thomas Jefferson. It contains key facts like dates, locations, spouse, political party, and awards. Knowledge graphs record that type of information in a machine-readable format. Now, remembering that generative AI can generate text based on facts, one can easily see how ChatGPT could compile several paragraphs in natural human language from the data we see here. Okay. Also shown at the bottom are other presidents as suggestions to expand the user's search. Again, this is information that is encapsulated in our knowledge graph. Okay, and all of these assets, if you will, in the knowledge graph and also the LLM are used to train the AI system. Knowledge graph output can be used in question answer systems, for fact generation, for intelligent search, and of course, generative AI. What I mean by intelligent search is you search for on a keyword and you get all kinds of related information, just like what we see here. And it's accurate. Okay. Knowledge derived through inference from a large language model is not necessarily accurate, and you don't know if it is. But this information is hard-coded in a semantic resource, and it has been vetted by a person. All right. Finished with my notes now. I can move forward more liberally for the rest of this presentation. Right. Actually, I do have some notes on this one, I think. Let me just find it. Yeah, this is my last notes slide. So this figure, the semantic content maturity model, this figure is also from Michael Iantosca, is one of my favorites. Michael has a holistic view of cognitive content, which he refers to as the semantic content maturity model. This model clearly shows the features and properties of the different types of external sources of knowledge that are used in RAG, and the dependency relationships between them. At the very bottom are the self-describing objects and micro-objects, intelligent content object containers. I believe he is referring here to content that contains embedded descriptions and definitions and is structured according to a markup standard such as DITA. Then there's the terminology, the source of linguistic truth for the content and for the organizational taxonomies that follow. Ontologies are modeled on the underlying taxonomies. And the knowledge graphs, in turn, are modeled on the ontologies. All of these assets are used to train the AI system. So here we have the intelligent content, then we have the semantic content assets, and all together they form a cognitive content framework, if you will. All right, that's my last notes. I can go more liberally now. All right, so what do the different things, ontologies, taxonomies, knowledge graphs, have in common? First of all, they are organized semantically. They have a semantic structure. They are based on concepts. They also have semantic rigor. In other words, there are clear descriptions and definitions. There are clear relationships, semantic relationships, the next point, between the various concepts and instances of those concepts. They're not incoherent. They're coherent. Okay, coherent systems, coherent resources. They are built on human knowledge. They're not scraped from the internet. Okay. And they contain granular levels of metadata. All of these features are features that form the core of terminology theory, principles, and methods, and have formed the core of this discipline for over 50 years. So none of this is new for terminologists and for the discipline of terminology. We have that foundation. We have the knowledge. We have a mature approach to this that we've developed for decades. All right, moving on. Now here's a nice quote from Michael Iantosca. Managed terminology is a prerequisite that must be developed before or in parallel with other semantic assets. An enterprise term base is the source of truth for all the words used in our taxonomies, ontologies, knowledge graphs, and in the content itself. So Michael Iantosca is saying, what he's saying here is that managed terminology is the foundation for all of these types of semantic resources, and those are the key for the future of AI. All right. All right, in this and the next couple of slides, I'm going to try to explain some of the fundamental concepts behind semantic resources. Okay. So this is the triangle. It's called the semantic triangle, sometimes called the Frege triangle. Frege was a philosopher who promoted this model. And he's not the only one. There were others too. So at the bottom left, you have the word symbol. Symbol is a visual representation of some object, which is called a referent. A visual representation can be either a word, linguistic, like a term or word or some text, or a picture. Okay. All right. So the symbol is usually linguistic. It's a piece of text, usually a word or a term. And that stands for something in the real world, which is called here a referent. But we also have the ability to mentally conceive of this idea, not necessarily write it down in language or speak it in language, but have a mental picture of it, mental idea of it. That would be called the thought or reference of that referent in the real world. So the symbol represents or stands for the idea, the object in the real world. Our thought, our mental conception of that is also a way of referring to the object in the real world. All right, so enough of that. On the right-hand side, it's easier to see how this thing all fits together. We have the symbol is the word dog in English. We could say that's a term, but also canine, Hund in German, chien in French, anjing in Malay, and that's Russian. I won't try to pronounce that. So different languages have different words for the same concept, the same object. On the right, I have a picture of a dog. That's the thing in the real world. That I have 2 dogs, the ones you feed and walk and so on. And then we have the concept in our head, and we can express that concept mentally and even linguistically by explaining it through something like a definition. A domesticated carnivorous mammal that typically has a long snout. Well, some of them have short snouts. An acute sense of smell, non-retractable claws, and a barking, howling, or whining voice. So that's what we have to deal with here. We have symbols, which are representative of concepts, which themselves represent things in the real world. Okay. Now, how does this work in terms of knowledge graphs? Well, terminology is what we have just talked about, the terms, what they represent, the concepts behind it. In general, that's what we are talking about when we're talking about managing terminology. Those concepts are usually a class of objects. Like the dog concept, the concept of a dog represents lots of different dogs, individuals in the world. There are millions of them on the planet, right? So it's a category of things as opposed to a cat or a bird, right? But on the right-hand side, what we're talking about is an instance of that class. So this is a picture of Sully, the dog that was President Bush's pet. This is a specific dog, Sully. So his name, there's a name of this dog, Sully. There's the picture of him. That's the instance of the class of dogs. And the description, we could say something like, he is the service dog of George Bush. So knowledge graphs are attempting to model relationships between instances according to relationships between concepts. This is why the theory and methods of terminology actually work here. All right, I'm going to give you another example here. Okay, we talked about Sully. He is the dog, or was the dog of George Bush. Okay, and so we can say that Sully is a dog. This is the category. Sully is as a single instance of a dog. That's a generic relationship, but going from the category to an individual. Sully the dog is the pet of George Bush. Or you could say, you could go in the reverse direction. George Bush has the pet, which is Sully. And George Bush is a president. That's, again, a generic relationship. The one at the top is associative relationship, but these two is generic relationship. At the bottom, we can have different instances. In this case, we could have Barack Obama, okay, also is a president. He also has a pet, and his pet is a dog, and his name is Bo. So for instances, we have names. For categories, we have terms. They all represent concepts. but going from categories to individuals. This is a very simplistic diagram, but it gives you an idea of what these knowledge graphs are. Let's see now, maybe down. Sorry. Okay. Now, in my conference in Malaysia, at the actual conference, I wanted to specifically address what this means for Malaysia and for the Malay language. How to put this in the context of their needs, okay? Well, we could say that Malay is an under-resourced language. I use that term quite loosely here. There are millions of people in Malaysia, and there are millions of people who speak Malay. But compared to a language such as English, which is pervasive throughout the planet, we would have to say it's a so-called smaller language, right? A so-called under-resourced language. Now, AI systems being developed today are largely being developed on large languages like English, because they have to be built on these large language models. These language models have to be very large. So building a fully performant large language model for Malay could be a gargantuan, a very big task. And I think the reason for that is not just that it's a so-called under-resourced language or a smaller language than English, but by the nature of the content that they have available today. There is, of course, a lot of digital content. They have a lot of websites. They have a lot of digital material, just like we do in English. Not so much as in English, but they are not, a non-technical society. They have the internet and all that stuff. But they also have a huge historical collection, if you will. How do you call it? They have a legacy. They have a huge legacy of content from their culture, from their history. And a lot of those documents are not in digital format. They could be books, archives, reports, and so forth. Now, you can't just take OCR, optical character recognition system, and convert these to digital. OCR does not do that. It produces a visual image of the text in general. So really, in order to make it digital, you'd have to almost retype everything. And of course, then you would also want to do things like make sure that it is highly structured using an XML markup format like DITA. So there's a lot to be done here in order to prepare an LLM that fully leverages the richness of the Malay language. Okay, so that's a really big task, and it's going to take a long time. Can we wait? Do we want to wait? Maybe not. Okay. If AI research is indeed moving towards the use of external sources of knowledge to enhance LLMs, why not go in that direction? Why not start to build those types of resources? So, given the weaker position of Malay on LLMs, on the existence of an LLM, why not leverage the terminology that they already have? And they do have terminology in Malaysia. They have a database. Why not leverage that terminology to build ontologies and knowledge graphs now? I just realized that this is a little bit small, so let me just pause this and make it bigger. All right, hopefully I didn't mess this up. All right, so why not build these external sources of knowledge for Malay? They already have terminology, and that if they can do that, then they will be able to build and use AI that is better performing, a better performing AI system than if they did not have these external sources of knowledge. Even if their LLM is still not great, at developing an AI system that uses that LLM, even if it's not a great one, but enhances it with an external source of knowledge, obviously that will perform better than having just a system that only uses an LLM. So we're going to have better performance by incorporating these external sources of knowledge. Now, in Malaysia, they have terminology resources. They have skilled terminologists. They have terminology know-how. So that's already a good start. We can use these resources, these people, this know-how, these skills, in order to build AI-enhancing external sources of knowledge for the Malay language. So I would suggest they move forward in that direction. And you could say the same for any other language, really. If we're going to acknowledge that these external sources of knowledge are the key to enhancing AI, we're going to have to start building them for multiple languages. Okay, moving forward. Okay, I'm going to now let Alan Melby speak for a moment. Alan Melby is a colleague of mine. He's a retired professor from Brigham Young University, and he was one of the earliest developers of machine translation systems. He has a PhD in computational linguistics. He is the brains behind the TBX standard, ISO 30042. He's heavily involved in translation quality standards and terminology standards. He has a huge experience in the field of language resources. So let's hear what he says. He's going to talk about distinguishing general language from domain-specific language through the use of metadata that has to be attached to what he calls lexical terminological units, or LTUs, and how terminologists are best positioned to do that and can and will be in high demand in the future. Let's get started.
We need people who understand the fundamental difference between domain-specific language and general language. These, we tend to, I think most people, I would never say that about this panel, but a lot of people don't really sense how different they are and how they need to be treated differently. So it brings us to metadata, and until we have reliable metadata about what I call a lexical terminological unit, which is kind of a cover term for a word or phrase in general language and a term in terminology work, until we shorten it to an LTU, until we have reliable metadata on these LTUs, so we know whether it's domain specific, what domain it's from, or whether it's general language, and that is in our text. It's part of structuring, and I think that people who really understand these two areas, general language and domain specific, understand the principles of terminology management, will be among those who are in high demand, as has been explained.
Okay, so what Alan was saying there is, he was touching upon this idea that the lexical terminological unit, so in other words, linguistic units that go beyond terminology in the classical sense and can include general language concepts and general language words. That's why he uses the term LTU. Now, what he's saying is we need to associate these LTUs with metadata to distinguish their usage as in general language or a special domain, a specific language. So this type of metadata can be encapsulated and is generally encapsulated in a terminological database. But terminology as a discipline needs to include this broader concept of the LTU. And I'll get back to that in a moment. Okay. Now, I will get back to what Ellen was saying a moment from now, because I'm going to talk about that using a different term. I'm going to use the word micro-content. So let's get back to that in a moment. But let's hear Michael Iantoska again about how terminology management is the foundation for building AI-enhancing semantic resources.
One point, and I think we still have a lot of work to do in business to educate the management team that I always say terminology is the foundation for these semantic sciences. That it is the source of truth for words. It's very simple. We're working with words. If we build taxonomies and ontologies and knowledge graphs and all this great semantic stacks without a solid foundation of term bases and terminology management, I often say we're building a building on it. It's a house of cards. It will fall down and collapse. It's a challenge because it's not the sexiest set of technologies when you're talking about the semantic sciences, and explaining, to senior management that we need enterprise scale work in this area rather than just delegating data and data management and master data down to the individual development teams, we have a lot of work to do to bring that to the C-suite and explain to them what this long-term investment means for the company.
So Michael is making the argument that terminology work is a hot topic right now. It's the foundation of these semantic resources that are going to enhance AI, but what he calls the C-suite. That's the corporate money holders and the corporate managers. They don't understand that. We have to raise their awareness about the importance of terminology management in various institutional environments. It's absolutely essential if they want to not only manage their content, produce translations in an efficient and high quality manner, and leverage NLP applications, including AI. Okay, let's move on. Now, this is where I get into the idea of micro content. So I'm kind of echoing what Ellen Melby said. Will terminology as a semantic resource be sufficient for AI? Okay, let's go back to the core meaning of terminology. That was one of my first slides in this presentation. The core meaning of terminology being a set of terms from a language for special purposes or a subject field / domain. That's what terminology normally means. The classical view of terminology is that it is language, terms in specific, that are confined to a language for special purposes, also known as a domain or a field of knowledge. But is AI confined to LSPs? LSP, for example, medicine, law, economics, video games, those are LSPs. They have their own language. They have their own terminology. Is AI confined to those types of sub-languages of our language? No, it is not. It is not. It's particularly general purpose AI systems. They have to cover all of human knowledge, much of which is very general in nature and not restricted to an LSP. So if we want to build these semantic resources that can feed AI systems, we have to unleash ourselves from the confines of LSP. We have to include more than just terminology in the classical sense. And so we have to adopt a new word for this, and I use the word microcontent. Ellen Melby uses the word lexical terminological unit to enable us to address more diverse use cases, more diverse applications of this data. However, regardless of what we call it, microcontent, lexical terminological unit, the data still needs to be managed according to the principles of terminology management, of terminology the discipline, because they are semantic resources, and terminology created the science for managing terminology, the discipline, created the science for managing linguistic resources semantically with a semantic structure. So what is microcontent? I tried to come up with a definition here. Microcontent is small linguistic units that, if captured and discretely represented in digital form, as in a terminology resource or terminology-like resource, can be consumed by an application or by a process to improve its output and performance, improve the output and performance of the application or process. Now, AI is a potential application of highly structured microcontent resources. So we not only include terms, which are listed here, but other words, names, slogans, expressions, maybe even visuals, icons, and smileys and stuff like that. What do you call those things? Smileys? Yeah. No, what is it called? There's this Japanese word, right? I can't remember. And okay, forget about that. I forgot the word. It's on the tip of my tongue, but you know what I mean. On your cell phone, those little things. Also slogans, as I said, expressions, maybe even morphemes, subunits of a word or term. Maybe collocations, which are connections between terms, and so on. So there's all kinds of different elements of language that can be managed semantically according to the principles and methods of terminology management that go beyond the concept of terminology per se. Okay, and we have to have that larger picture here. Okay, so we're getting close to the end of my answering the first question or the first part of my presentation. And hang on, don't worry, the second part is not so long, but we're getting close to the end of my first part. I'd like Michael Iantosca to say a few words here to put it all together. What is the key to good AI? He talks about structured content, metadata, and content intelligence through knowledge resources. And he ends up by naming this new generation of AI. He calls it explainable AI. Let's hear what he has to say. If I can get this to work. Come on. It's coming up, I think. Come on. Oh.
So a real core area that we can focus on is content intelligence. It's not enough just to take content and shovel it at AI. The most advanced AI today is coming back around. We talked earlier about neurosymbolic models. Named entity recognition is a key piece of identifying and managing the content. So if we can augment our content with controlled language, controlled vocabularies, taxonomies, if we can optimize the content itself, if we can augment it by labeling that content, so that when the named entity retrieval kicks in and we try to do inferencing and we try to do reasoning instead of just similarity retrieval and similarity search that's happening today, we're really headed toward the next phase of reliable, explainable, and accurate AI. It does not replace the human in the situation. It just makes it much more effective. Today, people are happy with 70 or 80% effectiveness. There is a theory that says as we get better, as we start reaching higher levels of accuracy, the dissatisfaction level of users and intolerance for mistakes is going to grow exponentially. So even as we, apply these technologies and hit the 90s and the high 90s, that tolerance for the last 5 or 10% is going to become very low. And we really need the linguistic and semantic intelligence. And that doesn't come free. You need to build the knowledge models. You need to enhance the content. You need to mine it. It is about the metadata, absolutely. And it's not just about the content metadata. It's about infusing the entire operations management with digital systems of record to go with managing all of this content. Today, companies are, or I should say engineering teams that are building AI, are scraping content from every which place you can possibly imagine in the company without regard to thinking about change management. And what does it have? Content knowledge does not stay static. You ingest content, those facts will change on you overnight. How are you going to do all that change management? And that has to do with the metadata, that has to do with the semantic intelligence, that has to do with intelligent content, as we call it. So there's a long road ahead here. There's a lot of time bombs that are ticking that folks aren't thinking about. And I think that we have a big role to play in the language space to help that.
All right, that was good. And when he said we have a big role to play, he's talking about people who can build and manage these knowledge resources. That's us. Okay. Okay, let's move forward. That concludes my presentation about the first component of the question of the theme of this conference, which is the relationship between terminology and AI. I started with how terminology can serve or enhance AI. So now I finished that. Thank you for thanks to Michael Iantosca's final words there. And now we can move on to the second part of the question: how can AI be in the service of terminology? How can AI help terminology? And again, I'm referring here to terminology, the discipline. Let's move on for that. All right, so first of all, I'm going to show you this very brief presentation by, or a very brief discussion by Yuri Belashov, who is a professor in the United States in the state of Georgia. He is an expert in AI and in its application to the language industry. So now he's not going to talk specifically about terminology managers here. He's going to talk about largely about translators, but also a little bit terminology managers. Let's see what he has to say. I can get this to work.
But on a more practical side, as a translator, I've been using AI, if you take it broadly, to include neural machine translation. I've been using it in my workflow for a long time, and now increasingly experimenting with LLMs in all aspects of my work, translation per se, but also terminology extraction and bilingual lexicon induction, those kind of tasks, also domain adaptation using translation memories and term bases, and editing, and more, actually.
Okay, so he gave you an idea here of the fact that AI can be used in various stages of terminology work and translation. We're going to get more into details in a moment on that. He mentioned translating using neural machine translation. He mentioned term extraction. And yeah, let's see what else then more. And this is Daniel Sebesta. He is a translator in Czech Republic. He also is an expert on AI in particular its use in the translation industry. He is also on the management board of directors, I believe, for FIT, which is the Fédération Internationale de Traducteurs, the International Association of Translators. So let's hear what he has to say about the use of AI in the language industry.
We generally view AI as a productivity tool, something to help linguists be more efficient, get more done, get rid of tasks they would rather not do, get access to new jobs, do things differently.
So that was very brief, but he did say that it was primarily used to enhance productivity of translators, and in particular to enable them to automate or semi-automate some of the tasks that they would rather not do or could save time doing. And this includes, for example, project management, automation of stages in a translation tool, a computer-assisted translation tool, pre-translation of texts using a neural machine translation, and then obviously that would involve a translator in machine translation post-editing, which of course not everybody's happy about, but it's not used everywhere. I'm speaking of machine translation here. There are many cases where a machine translation would be inappropriate, and as linguists watching this presentation with me, I'm sure that you know what I'm talking about. You would not use machine translation to translate a legal text, like a contract or an insurance policy, or any type of agreement. You would not use AI in the medical field or in any other type of legal document. Okay, you would not use AI machine. I'm speaking of machine translation here, mostly in to translate, for example, a work of literature. So there are very limited situations where machine translation is recommended or even tolerated, and that would include, for example, maybe some chat bots when you're visiting when your cell phone network goes down and you're visiting their website, and a chat bot will come to try to help you, and you'll have to converse with this machine, and that's using AI. And if it's in a language that the chatbot does not understand, it may invoke machine translation in order to converse with you with a translation step in between. So machine translation is used for gisting, for low impact or low risk content, but it's not used in many other situations, and we all know that. Okay, move down now. Okay. Now, so AI, we could say, is the terminologist robot assistant. I have a picture here of WALL-E. I hope you watched that movie. It's an animation movie, which I really liked. And he's a little robot that runs around and collects garbage, and he's a really nice guy. So anyways, ChatGPT is kind of friendly too, we could say. So what can you do with this robot? What can you do with a tool like ChatGPT? Well, a lot of people are saying you can use it to write a definition, one of the most frequent tasks that a terminologist does. And my colleague from Université du Québec à Trois-Rivières, Antonio San-Martin Pizarro, he's a professor at our university. He produced a video presentation on this topic, and it's available in YouTube. I encourage you to watch it. It's an excellent presentation. Just Google San Martin Pizarro and writing definitions. I'm sure you'll find it. If you have access to my presentation, you can click this link, but I don't want to click it right now because it's quite a long presentation, and so we don't have time. But I would encourage you to watch it. It's really well done. Okay, there are times when you can use it, AI for definitions, and sometimes when you cannot, and you must always recognize the limitations. You could use AI to suggest synonyms, and it usually does a pretty good job of that, but it won't be perfect. Some synonyms will be missing. Probably a good thesaurus is a better resource for finding synonyms. You can use it to do term extractions. Again, I'm not sure about this. I have tested it a little bit with a relatively small text using ChatGPT. Remember that I don't have the ability to upload a huge corpus to ChatGPT. I can only upload maybe a document or copy paste something in the window, the text window. So my experience is with relatively small corpora, and it does extract terms. But I would like to remind you that there are purpose-built term extraction tools available for doing term extraction. Like I mentioned Thermostat, but also Sketch Engine, Wordsmith. And these tools use a more sophisticated approach than ChatGPT or Copilot. They use an approach that involves the use of a reference corpus. They compare the corpus you upload, and you can upload a really big one if you want to, with this reference corpus, which is a general language corpus. And it can tell by comparing the statistical frequency of occurrence of your term in your corpus compared to how often it occurs in the reference corpus. They can use that data to rank this term or term candidate in terms of its domain specificity. And this actually works very well. I would encourage you to not assume that ChatGPT or Copilot or other generative AI systems are the most excellent tool for doing term extraction. I would rather myself do, I need to do this actually, a comparative study of the two approaches and see which one works better. I will personally assume that the purpose-built tools with the reference corpus are going to do a better job at this stage until proven otherwise. You can explore collocations, like what words go with artificial intelligence. Well, words like hallucination or LLM or RAG and stuff. It will come up with words that go with that. What words go with a certain verb? Undermine. What words go with undermine? What do you undermine? You undermine, I don't know. Anyways, it's just an example. You can enter a verb and ask it what nouns go with this as a subject or as an object and so on. Those are collocations. You can also use AI to find translations. However, I would not use it for that purpose. First of all, in terminology work, we don't translate terms. We find target language equivalents. Terms are not translated. You can't do that. You can translate a paragraph, you can translate a sentence, but you cannot translate a term because the target language itself may have a different way of expressing that term, that idea, that is not modeled on the way you have shown it in the source language. Let's say English is the source language. You have a term like garage sale. Well, you can't translate that garage sale because in other languages, they may convey it differently. In French, for example, they use a different expression. They call it sale of unwanted items, vente débarras, sale of unwanted items. They don't say sale of the garage. So you see what I'm saying? We don't use translation approach in terminology. We use a corpus-based discovery approach, trying to find equivalent expressions in the target language using an authentic target language corpus. Now, maybe AI can be used for other tasks. I haven't necessarily got a complete list here, but in every case, use caution. I have been told, for example, by colleagues of mine, that you shouldn't really use AI to answer a question that you don't already know the answer of yourself, or at least have a general idea of the answer. If you're totally ignorant of the answer to this question, then you're going to be relying on total accuracy for the AI response, and you don't know that it's accurate. So it's best to at least have a general idea of what the answer is, so that you can then vet the response from the AI system and at least maybe detect when there could be a problem. Okay, moving on. Now, this slide and the next one is from a website I found, JobsGPT by SmarterX.ai. You can Google that. SmarterX.ai is an AI company, and they have this application called JobsGPT where you can enter the name of a profession and it will tell you according to its data. I don't know where it gets its data from, honestly, but it will produce a report like this that tells you how AI is impacting that profession. So I entered the word terminologist or terminology management. I can't remember exactly, but terminologist probably. And it came up with these figures that, for example, the use of AI can save the time of researching terminology by 50%. It can save the time of creating and maintaining terminology databases by 30%, and so on. Now, I don't necessarily agree with these figures. I'm just showing them to you because this website does exist, and we have to take it with a grain of salt. So yeah. For example, the creating and maintaining terminology databases, I don't see how AI can even do any of that. But it's suggesting here that specialized software integrated with LLM capabilities could help. So what they're saying here is that certain terminology management systems like TermWeb, the one I showed you earlier, if it has a direct integration with an AI system, then that offers the terminologist the possibility of using AI, here and there as they need to perhaps suggest a definition or suggest synonyms or, excuse me, find collocations and so forth. Excuse me. Let me just pause this and get some water. Okay. By the way, we're almost finished, so hang in there. I would not use an AI system to translate terms for the reasons I just explained. No. That's dangerous. Okay, I'll let you, I'm not going to read through this slide or the next one. Running out of time here. Let's move to the next one. Here's some other thing, conducting terminology audits. This one has 0%. Don't mention that. Writing and editing terminology guidelines. Training staff. Keeping up with industry standards. I really don't necessarily agree with these figures. They're a little bit generous, to say the least. But the point here is that AI can probably be used by terminologists in certain ways for certain tasks to increase their productivity. Okay, so we can certainly agree on that. All right, now some of the dangers of using an AI system, it's in terminology work, is the same as the dangers I expressed earlier: the possibility of errors, biases, plagiarism, out of context information, and in particular the lack of the source. Terminology work heavily relies on having a level of trust of the information by virtue of knowing its source. We insist, for example, in terminology work that every piece of information we use has a source, and we know what that source is. Now, when you use AI, you don't know the source of anything. So that's why we have to always take the information that it provides with a grain of salt. In terms of terminology work. Okay, moving down, almost done here. Now, my colleague Antonio San Martin Pizarro did talk in his video about terminography, and in particular, post-editing terminography. Now, the word terminography, I didn't really introduce this earlier, but what it means is the practical side of terminology work, the actual hands-on doing terminology work, like in a database, writing definitions, finding synonyms, adding metadata. That's terminography. So he does acknowledge that AI is coming into the picture here. And so he therefore has introduced the term post-editing terminography along the same model as post-editing machine translation. If you use a machine to do a translation and then you are going after and post-edit it. Same way for terminology. If we use a machine to help us do our job in terminology, then we are doing a form of post-editing to vet that information. So he defines it as AI-assisted terminography, in which the machine produces a terminographic item, for example, a definition, and then the terminologist corrects or refines it. Okay. Now, Antonio has come to the conclusion that AI is coming into our profession, a terminology profession, and it will continue to be part of what we do. So let's read what he says here. The integration of AI into terminology work appears inevitable. To remain competitive and relevant against AI tools such as ChatGPT, terminologists will need to embrace AI and develop the necessary skills for its efficient integration into the workflow. I foresee a future where AI-assisted terminography will be synonymous with terminography itself. So in other words, he's predicting that in the future, we will be using AI a lot. Or at least we will be using it to some extent as we are doing terminology work. Okay, I can agree with that. But AI does have its limitations and we need to be careful. AI cannot, for example, assemble a coherent and standards compliant terminological entry. It cannot provide authentic context. Now, this is important. A context in terminology work is a sentence that contains the term. Often we will include a context, a sentence containing the term, in a terminological entry. We saw some in the screenshots of my students' work earlier. And we do that because, well, first of all, contexts, these sentences are relatively easy to find. You can Google and find them very quickly. And definitions, on the other hand, are more difficult to produce. And in some applications of terminology resources, we don't need definitions all the time. Definitions are nice, but they're not always mandatory. So in those types of entries, the terminologist will often include a context sentence in lieu of a definition. These context sentences can contain clues about the meaning of a term, after all. They can contain clues about how a term is used, what subject field it's part of, and so forth. However, and this is a golden rule in terminology work, these sentences, these context sentences, must be authentic. And by that I mean they must exist somewhere. The terminologist cannot invent one. Even though it's relatively easy to do so, anybody can invent a sentence that contains a term. We can't do that. We're not allowed. We have to provide sentences that exist somewhere, that have been already produced. And that's why we call them authentic. Now, you can't use ChatGPT to get authentic context because you don't know where the sentence came from. And in fact, ChatGPT may have invented it itself. We cannot use machine-generated language in a human-vetted terminological semantic resource. You cannot do that. You can't use AI to verify the authenticity of anything. You can't use it to ensure contextually relevant and accurate data. You can't use it to establish complex semantic relationships. You can use AI, ChatGPT, etc., to find semantic relationships. You can ask them questions that would lead to that information, okay? But I'm talking here about creating a comprehensive, fully annotated, complex network of semantic relationships. Maybe you can use AI a little bit to get to that point, but no, not for the whole thing. And of course, quality control. So AI should always be used with a degree of, with a certain degree of caution. Okay. So I'm almost finished my presentation. I think this is the second last slide. My conclusion here about the two sides of the question. Terminology as a discipline provides the theoretical and methodological framework for developing AI-enhancing linguistic resources. Vetted terminological data is the foundation upon which those resources are built. To play a key role in the future of AI, terminologists and other linguists must, first of all, apply principles of structured semantics in the development of term bases. So by this I mean develop term bases that contain semantic relationships. Not all term bases do today, okay? But we have the capabilities of doing that. We have the know-how. We have the software that can permit that. We need to go there, okay? We also need to become experts in the development of taxonomies, ontologies, and knowledge graphs. On the other hand, AI can be used by terminologists to help them do certain tasks. Oh, is that my last slide? No, one more. Okay, so this is my final slide. I have the logo here of the Malaysian Translators Association, for whom this presentation was originally created, and other communities in Malaysia as well, other language communities. So my colleague, another colleague of mine from IBM, Mike Dillinger, he has said, language professionals have superpowers that are both in short supply and essential to the next stages of AI's development. So this is interesting. So Michael Iantosca isn't the only person talking in his terms, in the terms that he described. We have other AI experts like Mike Dillinger that say the same thing. And in fact, if you go to LinkedIn and just browse some of the discussions going on right now about AI, they're all saying this. They're all talking about knowledge graphs. They're all talking about semantic networks. They're all talking about the importance of cohesion and coherence of semantic information, metadata, markup, all of that stuff. And this is my final quotation here. To remain competitive and relevant, language professionals must assume their privileged position and apply the principles of terminology management to create AI-ready semantic microcontent resources. So that's my final message. I believe I have proven that terminology and terminologists have an important role to play in AI. And I've also demonstrated that AI can be used with a certain amount of caution in helping terminologists to do their work. Thank you for watching. I hope this hasn't been too long. I hope you've enjoyed it, and have a great day. Bye for now.